It's another beautiful day to learn physics. Welcome to our channel. If you're here during the previous video lessons, how are you with your studies of the previous topics? From measurement up to the freely falling body. I hope you have learned what you are supposed to acquire from those presentations. Today, the topic of discussion is projectile motion. The focus of discussion is the horizontal and vertical distance traveled and the duration of the motion of the body. To learn all of this about projectile motion, it is advised that you view this video lesson up to the end. And to be able to view all other video lessons, prerequisite to this lesson and the videos coming after this lesson, subscribe to this channel. This ball can be moved along the horizontal with constant velocity or uniform motion, or increasing velocity, thus an accelerated motion. This ball can be moved along the vertical, upward or downward. The ball is a freely falling body and accelerating downward with an acceleration equal to the acceleration due to gravity, g. The horizontal motion of the ball has a uniform motion. The instantaneous velocities v sub 1, v sub 2, v sub 3 up to v sub 9 are equal. The average velocity bar v is equal to the instantaneous velocity, the total time of motion t, and the distance traveled x. The distance traveled x is equal to the product of average velocity and time of travel. The discussion about uniform motion you may have viewed earlier. If not, you can view such in the video lesson titled Describing Motion here in this channel. The horizontal motion of the ball has a uniformly accelerated motion. The initial velocity v sub I, final velocity v sub f, where the final velocity is greater than the initial velocity. The acceleration a is in the same direction of the velocities and the distance traveled x. The quantities involved can be obtained using the equations of kinematics. The first equation is final velocity is equal to the sum of the initial velocity and the product of acceleration and time. The second equation is the distance traveled is equal to the sum of the product of initial velocity and time and half of the product of acceleration and the square of time. The two equations of third equation of kinematics are the distance traveled is equal to the ratio of the difference in the squares of the final and initial velocities and twice of the acceleration, and the square of final velocity is equal to the sum of square of initial velocity and twice of the product of acceleration and total distance traveled. These equations of kinematics were discussed in one of the video lessons in this channel. You may view this lesson if you have not viewed this or you want to review on this topic, the video lesson on equations of kinematics. The vertical motion of the ball, a freely falling body, is either upward or downward. The modified equations of kinematics for freely falling bodies are the first, the second, and the third equations. The first equation is vertical final velocity is equal to the sum of the initial velocity and the product of acceleration due to gravity and time. The second equation is the vertical distance traveled is equal to the sum of the product of initial velocity and time and half of the product of acceleration due to gravity and the square of time. The two equations of third equation of kinematics are the vertical distance traveled is equal to the ratio of the difference in the squares of the final and initial velocities and twice of the acceleration due to gravity. And the square of the final velocity is equal to the sum of the square of initial velocity and twice of the product of acceleration due to gravity and vertical total distance traveled. You may review the discussion on these modified equations in the video lesson on freely falling bodies, also from this channel. What if this ball was thrown upward at an angle from the horizontal? The initial velocity v sub 0 at an angle from the horizontal theta sub x. The ball moved in curved path, upward then downward, with both horizontal and vertical distance traveled. The parabolic motion of a body in the air under the action of gravity is known as projectile motion. The body in motion, the ball, is called a projectile. The curved path is called the trajectory. V sub 0 is the initial velocity of the projectile. Because it is acting at an angle from the horizontal, theta sub x, the x component of the initial velocity, v sub 0, is v sub 0 cosine theta sub x. The y component of the initial velocity, v sub 0 sub y, is equal to v sub 0 times sine theta sub x. The instantaneous velocities v sub 1, v sub 2, v sub 3, v sub 4, v sub 5, v sub 6, v sub 7, and v sub 8. The x and y components of these velocities. Notice that there is no y subcomponent at v sub 4. This is the highest point reached by the projectile. And the x and y components of v sub 5, v sub 6, v sub 7, and v sub 8. Now let's observe the motions of the projectile separately. The upward motion. Along the trajectory at v sub 1, the position along the vertical and the horizontal velocities are v sub 1y and v sub 1x, respectively. At v sub 2, the position along the vertical and the horizontal velocities are v sub 2y and v sub 2x, respectively. At v sub 3, the position and velocities along the x and y axis. At v sub 4, the position and velocities along the x and y axis. After this position, the projectile is moving downward. At v sub 5, the positions and velocities of the ball along the x and y axis. At v sub 6, the positions and velocities along the x and y axis. At v sub 7, the positions and velocities along the x and y axis. And at v sub 8, the positions and velocities along the x and y axis. The positions of the projectile showing the motion along the x and y axis. The projectile motion consists of both vertical and horizontal motions independent of each other. The vertical motion of a projectile is the same as a freely falling body. On its upward motion, the vertical velocity is decreasing. On its downward motion, the vertical velocity is increasing. It has a uniformly accelerated motion. the horizontal motion of the projectile. The instantaneous velocities are equal. Thus, the velocity of the ball is constant. The horizontal motion of the projectile is uniform. Focusing on the vertical motion of the projectile. The time to reach the highest point of the trajectory, t sub up. The time to complete the trajectory at the same level from where it started is twice of time sub up. The highest vertical distance covered by the projectile is the h sub max. It is the same as the highest vertical distance traveled by a freely falling body. Following the modified equations of kinematics for freely falling bodies, the time to reach the maximum height is t sub up equals the ratio of the difference of final velocity and initial velocity and acceleration due to gravity. The maximum distance vertical covered by the projectile is h sub max equal to y, which is equal to the sum of the product of initial velocity and time and half of the product of acceleration due to gravity and the square of time. The equation for projectile motion can be derived from the equations of kinematics for freely falling body. For the time to reach the highest point of the trajectory, T sub up equals V sub F minus V sub I over G. Note that the initial velocity of the projectile is V sub 0 along the y-axis, which is equal to V sub 0 times sine theta sub x. And the final velocity V sub F is equal to the V sub 4 sub y, or the vertical velocity of the projectile at the highest point of the trajectory, which is 0. The acceleration due to gravity is negative 9.8 meters per second square. Substituting the initial velocity, final velocity, and acceleration due to gravity to the equation above. To avoid negative equation, we substitute the negative value of acceleration due to gravity. With this, in equations of projectile motion, the negative sign of acceleration due to gravity is already integrated. Results 2. Time sub up is equal to the ratio of the product of V sub 0 and sine theta sub x and acceleration due to gravity. The time to complete the trajectory of the same level, 2t sub up, is twice of the product of V sub 0 and sine theta sub x and acceleration due to gravity. For the maximum height reached by a projectile, which is equal to the highest vertical distance covered by a freely falling body, substitute the initial velocity and time obtained earlier. H sub max is equal to the sum of the product of V sub 0 sine theta sub x and the ratio of the product of V sub 0 and sine theta sub x and acceleration due to gravity and half of the product of acceleration and the square of the ratio of the product of V sub 0 and sine theta sub x and acceleration due to gravity. Multiplying the factors results to V sub 0 square sine square theta over g plus 1/2 g times V sub 0 square sine square theta sub x over g square. Notice that the equation contains 3 g's. Are these g's equal or the same? If you say no, you're right. To make all the g's the same, substitute the negative sign for this g. And this makes the second term of the equation negative. Now, the common denominator is 2g. And the numerator is the difference between 2v sub 0 square sine square theta sub x and v sub 0 square sine square theta sub x. The result is h sub max is equal to the ratio of the product of the square of v sub 0 and the square of sine theta sub x and 2g. This is the equation for the maximum vertical distance reached by a projectile. The horizontal motion of the projectile. The horizontal distance covered by the projectile is called range, r, which is equal to the x, or distance traveled by a body with uniform motion. The range r equals x is equal to average velocity times the time of travel. The average velocity is equal to the x component of the initial velocity, v sub 0, and the time taken is twice of time sub up. With this equation, the average velocity is equal to v sub 0 sub x and is equal to v sub 0 cosine theta sub x. Time sub up is equal to the ratio of the product of v sub 0 and sine theta sub x and g. The range r is equal to v sub 0 times cosine theta sub x times 2 times the ratio of v sub 0, sine theta sub x, and g. Performing the multiplication results to the ratio of 2v sub 0 squared, sine theta sub x, cosine theta sub x, and g. In trigonometry, sine theta sub x, cosine theta sub x is equal to 1/2 sine 2 theta sub x. Replacing the equivalent and performing the operations, the range r is equal to the ratio of the product of square velocity sub 0 and sine 2 theta sub x and acceleration due to gravity g. Let's have the first example problem. A soccer ball was kicked off with a velocity of 25 meters per second at an angle of 40 degrees from the ground. How high did the ball go? How long did it take for the ball to fall to the ground? How far from the point of the ball was kicked off did it land? The illustration shows the trajectory of the ball. The quantities required in the problem are t sub up, h sub max, and r. The given information from the problem: initial velocity v sub 0 is 25 meters per second, and the angle of launch theta sub x is 40 degrees. The formula to solve the unknown quantities are: A, the time to reach the maximum height. Time sub up equals the ratio of v sub 0 sine theta sub x and g. B, the maximum height, h sub max equals the ratio of the product of the square of v sub 0 and the square of sine theta sub x and 2g. C, the range r is equal to the ratio of the product of the square of v sub 0 and sine of twice of theta sub x and g. Substitution and calculation. Solving for the time to reach the maximum height, time sub up. Substituting the values of initial velocity, the angle of launch, and acceleration due to gravity. The value of sine 40 degrees is 0.643 multiplied by 25 meters per second is 16.075 meters per second. Then divide by 9.8 meters per second square. Times sub up equals 1.64 seconds. The maximum height, 8 sub max, substituting the values of initial velocity, angle of launch, and acceleration due to gravity to the formula stated earlier. Determine the equivalent of sine 40 degrees first before squaring it. Square the initial velocity, multiply 2 and 9.8 meters per second square. The product of 625 meters square per second square and the square of 0.643 is 258.41 meter square per second square. Divide by 19.6 meter per second square. The 8 sub max is 13.18 meters. The range are: substitute the initial velocity, angle of launch, and the acceleration due to gravity to the formula stated earlier. Square of 25 meters per second is 625 meters square per second square. Multiply first the angle of launch by 2 before finding the value. Sine 80 degrees is equal to 0.985 multiplied by 625 meters square per second square. The product is 615.625 meters square per second square. Then divide by 9.8 meters per second square. The range R is 62.82 meters. Don't forget to write the final answers. Time to reach the maximum height is 1.64 seconds. The maximum vertical distance reached by the ball is 13.18 meters. And the horizontal distance range R covered by the ball is 62.82 meters. What are some examples of projectile motion? The motion of the ball thrown to the basketball. The motion of the water coming out from a nozzle. A volleyball service. And many other sports shows projectile motion. When an object is thrown at an angle from the top of a building, and the motion of cannonball fired. At what angle should a projectile be launched to have the greatest range? Let's consider this ball and the projectile to show the angle of launch. Taking this angle of launch 20 degrees, 30 degrees, 45 degrees, 60 degrees, 70 degrees, and 90 degrees. With the same initial velocity, v sub 0, which angle of launch will have the longest horizontal distance covered? Let's observe the trajectory at 20 degrees, at 30 degrees, at 45 degrees. Notice that the range increases from 20 degrees to 45 degrees. How about at 60 degrees, at 70 degrees, and at 90 degrees? The trajectory decreases from 45 degrees to 90 degrees. The diagram shows that the greatest range is attained when the projectile is launched at 45 degrees. Let's prove this using the formula R is equal to the ratio of the product of the square of initial velocity and sine 2 theta sub x and acceleration due to gravity. Range is maximum when sine 2 theta sub x is equal to 1. Sine 90 degrees is equal to 1. Thus, 2 theta is equal to 90 degrees. Theta is equal to 45 degrees. This proves the illustration that the maximum range can be attained at 45 degrees. So if you are playing sports like shot put, javelin throw, discus throw, archery, or ball games like basketball, volleyball, soccer, football, aim to release at 45 degrees to attain the greatest range. Let's have the second example problem. A man on top of a building 30 meters high throw a ball with a speed of 18 meters per second at 30 degrees from the horizontal. What was the velocity of the ball when it hit the ground? How far from the foot of the building did it land? At what angle from the horizontal did it land? The given illustration and the required. The man is about to throw the ball. With the initial velocity, this is the trajectory, the final velocity. Considering 3 points A, B, and C for the motion of the ball, A at the top of the building, B at the highest point reached by the ball, and C the point where the ball landed. The height of the building is 30 meters. The angle of launch is 30 degrees. And the initial velocity is 18 meters per second. First unknown quantity is V sub C. The second unknown, the horizontal distance traveled x. And the third unknown is the angle of landing, theta sub L. The formula to solve for these quantities, the velocity V sub C is equal to the square root of the sum of the square of V sub C sub x and V sub C sub y. This is the Pythagorean theorem because V sub C sub x and V sub C sub y are perpendicular. These are the components of V sub C. V sub C sub x is constant and is equal to the x component of the initial velocity V sub A. V sub C sub y is the vertical velocity of the ball when it hit the ground, which from the first equation of the kinematics is equal to the sum of y component of the initial velocity and the product of acceleration due to gravity and the time of travel of the ball. So what is the time of travel of the ball? Time of travel, t is equal to the time from A to B and from B to C. The time to reach the maximum height times sub AB, the time of travel from B to C is derived from the second equation of kinematics. What is y sub BC? The vertical distance from highest point reached by the ball to the ground is equal to the y sub AB plus the height of the building. Y sub AB is the same as y sub max, the highest vertical distance reached by a projectile. To solve for the horizontal distance covered by the ball, x is equal to the average velocity times the time of travel. Average velocity is equal to x component of the initial velocity. The angle of landing, theta sub L, is equal to the inverse tangent of the ratio of the y component and the x component of the velocity sub c. Substitution and calculation. In solving for the first required quantity, using the working equations earlier, use backward direction, starting from the last working equation. Substitute the given initial velocity, v sub A, angle of launch, and the acceleration due to gravity. Square the initial velocity, find the value of sine 30 degrees, then square. Multiply 2 and 9.8 meters per second square. Y sub AB is equal to the ratio of the product of 324 meters square per second square and the square of 0.5 and 19.6 meter per second square. Divide by 19.6 meter per second square. Y sub AB is equal to 4.13 meters. Y sub BC The distance from the highest point of the trajectory and the ground is the sum of 4.13 meters and 30 meters. Y sub BC is equal to 34.13 meters. The time from the highest point to the ground is square root of 2 times negative 34.13 meters divided by negative 9.8 meters per second square. Why is the 34.13 meters negative? Why is the acceleration due to gravity negative? The reference point in this item is point B, the highest point, and the ball is moving downward. The displacement of the ball is directed downward. Likewise, the acceleration due to gravity is negative because this is a freely falling body formula, not a projectile motion formula. Performing the operations, the time for the ball to travel from point B to C is 2.64 seconds. Continuing the solution, the time to travel from point A to B is the product of 18 meters per second and sine 30 degrees divided by 9.8 meters per second square. Sine 30 degrees is equal to 0.5. Time sub AB is 0.92 seconds. The time of travel from A to C is the sum of 0.92 seconds and 2.64 seconds. Time T is 3.56 seconds. The y component of the velocity when the ball hit the ground, v sub c sub y, is equal to the sum of 18 meters per second and the product of negative 9.8 meters per second square and 3.56 seconds. The acceleration due to gravity substituted is negative because the equation is for freely falling body. Performing the operations, v sub c sub y is equal to negative 16.89 meters per second. The x component of velocity sub c is constant and is equal to the x component of the initial velocity, 18 meters per second cosine 30 degrees. Cosine 30 degrees is equivalent to 0.866. The x component of v sub c is 15.59 meters per second. The velocity sub c is equal to the square root of the square of x component and square of y component. Performing the operations, the velocity when the ball hit the ground, v sub c, is equal to 22.99 meters per second. Solving for the second required in this problem, x is equal to the product of 18 meters per second cosine 30 degrees and 3.56 seconds. Cosine 30 degrees is equal to 0.866 multiply, and the result is x is equal to 55.49 meters. The third required is angle of landing. Theta sub L is equal to the inverse tangent of the ratio of the y component and x component. Negative 16.89 meters per second divided by 15.59 meters per second. Theta sub L is the inverse tangent of negative 1.083. Theta sub L is equal to negative 47.29 degrees. Negative because it is measured from negative x-axis. The final answers are final velocity or velocity of the ball when it hit the ground, v sub c is 22.99 meters per second. The horizontal distance from the point of the building to the point where the ball hit the ground is 55.49 meters. Angle of landing, theta sub L, is negative 47.29 degrees. This time, let's find out how far have you learned the topic, projectile motion. Solve the following problems completely. Use one page of paper for each problem. After you have solved the problem, have your solutions checked by your instructor or professor. Number 1. A ball was thrown horizontally at 20 meters per second from a window of a condominium unit and hit the ground after 1.4 seconds. A. What is the height of the window from the ground? B. What is the velocity of the ball when it hit the ground? Number 2. A baseball player hit the ball with a bat with 30 meters per second speed at 40 degrees from the horizontal, but was caught by the fielder on its way down. A. How long did it take for the ball to reach the maximum height? B. How high did the ball go? And C. How far from the batter's position did the fielder caught the ball? Number 3. A stuffed toy was thrown at 24 meters per second horizontally from the bridge 25 meters high above the water towards the direction of the boat approaching the bridge by 8 meters per second. If the toy fall into the boat, how far was the boat from the bridge when the stuffed toy was released? I hope you have met the objectives for this video lesson, that you have learned about projectile motion. If you find this video lesson helpful in learning the topic, projectile motion, and feel that other students will also learn from this, don't forget to like and share this video. If you have not subscribed, I request that you subscribe now to this channel, so you may view all the learning videos here and will be notified of the upcoming presentations ahead. Thank you for watching this video. Keep safe and good luck.